Okay, it seems to be like that. Morning, everyone. There's a few things I'm going to give an introduction to today. We're starting with Bookmark Manager, which looks like this. But this is going to really sort of complete our kind of knowledge of building a web application. By complete, obviously, there's millions of ways to build a web application, but it's going to really sort of like give us the complete package, so to speak. So we have that diagram which Sam keeps showing us, that really complete really confusing diagram. But at the end of that, you'll see that there's like a database. So now, after this week, we should have the package as far as a server, abilities from a browser to talk to our Ruby code, some sort of package which is where our code's written. So we're going to be using Ruby for that, and we're going to be introducing databases. And really today, you're going to get stuck in pretty much straight away. So the Bookmark Manager challenge goes straight into databases. Our site is going to look like this. Can anyone see where the database interaction is going to be with this? Yes, Richard?
Links.
Links? Okay, yeah, so sorry?
The listing of links on the front page.
Yep.
Sign up.
The sign up? Yeah, exactly. Sign up. Adding and removing links, yeah. Sign in. Yes. So what's this sort of sign in area going to be? So signing in, how's that going to, what's going to be in the database for that?
Email password.
Email password. User information, pretty much. So we can keep going back. We have a whole bunch of users in our database, and then we can say, okay, whoever's got this password and this email address, that's the person who signed in. So email's going to look at that later on in the week. Then we have these links. What's in the link here? That will be saved in the database. What's going to be in the link that's going to be saved in the database?
Partial description, URL.
Maybe an author. We've got some sort of added yesterday, so some information about when it was saved. Yeah, and what's going to be, when you click on this, what do you expect to happen with this kind of application?
To go through this website.
To go through this website, so you said URL as well. Just, we can't see the URL here, but there will be a URL also saved in our database. So databases are hugely powerful. When you see databases in sort of diagram form, I can't see a pen. Does anyone know what the symbol of the drawing of a database looks like? Does anyone know what the database drawing looks like? Yeah, so you see that when I first started at my company, I didn't really, people just kept drawing this everywhere I went, sort of this sort of symbol. If you see that, that means database. That means just a form of database. Can anyone think of any names of databases? Which sounds like a really silly thing to say. Yeah. Stack. I guess what I was going for, so you have something, this might be saved as something like users underscore DB. With the file that we saved in.
Do you mean applications that use databases? Like
yes. No. I mean more.
Do you mean tables?
Types of databases.
Relational databases.
Yeah, relational databases. What is a relational database?
I'm not sure.
Okay. I mean, it's a database that has certain relationships. I guess one way of saying that. I guess what I was thinking is like you might have seen like a few years ago, in particular, like PHP and MySQL. It's like the answer to all our problems. Like MySQL is a really, really popular one. And that's a database that you're seeing pretty much all this one of the most popular databases you can get. There's also one called Postgres, which is PostgreSQL. That's one that we're going to be using. Yeah, exactly.
Oracle, SQL Server.
Yeah, and the list really goes on. But one thing that you'll keep seeing is this repeated over and over again. It's a SQL, SQL. And, yeah.
Are those databases themselves, are they languages for query databases?
That's a fantastic question. These are databases. So SQL, Postgres, SQLite you mentioned, Mongo, they're all they are the databases. They are, and Microsoft have their own one. We used to use Microsoft when I worked in C# a few years ago. It was Microsoft SQL. And the reason why you should never use that is because it's really expensive. You have to pay for the licenses. A bit like your Windows on your computer, it costs like £100 for the license just for Windows. For the database license, you have to pay an enterprise license. So these are all database companies, so they've come up with the instruction and the program to talk to them. This is the language, just like SQL. So that is actually the language that this is written in. So this is MySQL, SQL. SQL is the language that you're going to be talking to the database with. And it stands for Structured Query Language. So Structured Query Language. And many years ago, you would have to write directly into the database your SQL. So you'd have to. I would always recommend. So we don't really teach SQL at Makers Academy, and I've spent many years having to write my own SQL scripts. And a SQL script, if we try and find a select statement here, we would have select column name from table name. It's actually really, as a language goes, it's extremely basic. There's not too much to it. If you memorize all of these, then you know how to write SQL. There are gigantic books written on SQL language, so please don't think that it's particularly easy to write. We could do a 12-week course just on SQL alone. However, to get the basics of just writing your normal sort of queries, it's actually quite easy. So I'm going to show a few examples of what SQL might look like.
Is it something that's fairly unchanged? Because
yes,
I grabbed the SQL cookbook. I was a little bit concerned that it's quite old.
It's welcome to be 20 years old and it'll be fine. Yeah, it hasn't changed too much. So it's not like Ruby where you have a new version, which have huge changes going on, and you have to learn new parts of the language. If you know how to write SQL, that would be pretty much good for any of the SQL types of databases. The one that we favour at Makers Academy in particular is, a lot of the open source community is Postgres. It's free, it's open source. It's extremely fast and powerful. It's one of the best ones you can use. MySQL is normally a little bit slow, and SQLite is a bit faster. But Postgres is definitely favoured within the community. And if you go through the Bookmark Manager tutorial, might have to press back here. It's going to give you an instruction of how to actually start installing your database. So we have Gems, which installs sort of Ruby programs for us, and we have Brew install, which installs active applications inside your computer. So when you install Postgres, it could be good for maybe JavaScript and Node, as well as it is for Ruby and Sinatra, which we're going to be using it for. So once you've installed Postgres, you have this fantastic, let's make it a bit bigger, commands on your computer, so make sure it's definitely installed correctly. Who here has installed Postgres already? So who here hasn't installed Postgres already? It might be easier. Okay, that's fantastic. Okay, so if you type in PSQL, you should get your prompt where you can start writing Postgres commands. So I recommend this sheet here for everything you need Postgres related. There's not many, it's a tiny list. So from here up to here, you should never have to write any more Postgres commands to get anything going. So I can send that around to you. Cheat sheets are fantastic. They're not cheating, it's just learning. I'll send that out. You don't see December.
So where is that?
Thank you. There you go. I'll send that out. It's a really useful link to have, and I'll send it around. This is just W3 Schools SQL introduction. So we've got this list of commands here. So it's one question as I was setting that out. Okay.
Sorry. The might be possible.
Yeah, MongoDB will fall into your NoSQL area, so you're not writing SQL. So if we're falling out of this patterns in SQL. Right now, probably the quickest way to, so when we're dealing with Ruby, we have certain data types that are given to us by Ruby. So we have arrays, as a way to store some sort of data, and we have hashes. MongoDB is really similar to hashes. So you have that key value pair for all of your information. So your ID is a key, and the value could be the entire document. And inside there, you'll have key of name, value of Stephen, and so on. It's built up with much like hash using JSON. So it's more JavaScripty. Any other questions? Okay. So once we've installed our Postgres, once it's fully working, we can make some queries. So we can go for our cheat sheet. We can list all of our databases. So I'm going to have quite a few databases because I've worked on a few projects whilst I've been here. And now I can connect it. These are all of my tables. What is a table?
Stores data.
Stores data. Think of them like these are your Excel spreadsheets. So all it is just a big table, just like you would store in Excel. You'd have, and each one of these is for a particular website. So Bookmark Manager, you can see close to the top. That's my my folder with all of my Excel spreadsheets. Let's maybe not use Excel because I don't use Excel because I can't. But it's a spreadsheet, and inside here I will have all of my information for my Bookmark Manager. I haven't got much of my Bookmark Manager because I've just started building this up again. But let's connect to. Who should we connect to? Maybe SnappyGram. That one looks quite good. So to connect, I'm going to do in SQL. You'll see a lot of commands. /Q will quit. So if you ever get stuck here and you want to leave, do /Q, and that will get you out of Postgres. So I think that's the most important command to learn is how to exit every time you learn something. So I can go back in. Now if I want to connect to any one of these, I can connect by doing /C for connect, and I'll go for SnappyGram development. And it says you're now connected to SnappyGram development. And I can start making queries on here. So I could have a look at all of my tables that I've got. So let's list out all of the tables, list tables in connected database. So you take.
Sorry, was that a database of databases that you just said?
Yeah, database of tables. So this is the database that I've connected to, SnappyGram development.
Yeah.
And now if I want to list out all of the tables inside here, you see these are all of my my tables. So inside users, I'm going to have a list of the email addresses and usernames and something like passwords, probably not actually passwords. And yeah, I can query with these. These are really sort of like the sheets inside my big sort of database with all of my information that I want. And I can, sorry? Well, these are more sort of like the folder where everything's contains. This is the database. And when you connect, these are the tables. These are the rows of information that you have here. So if you select star from users, you'll see that I've got, make it a little bit smaller. Yeah, it's me. That's quite sad. I'm the only user here. Actually, I've got 2 users, I think. Is that too small? It's too small. Okay, I'll make it bigger, but we're going to lose a little bit of information. It's got 1 row, so there's quite a bit of information in there. It's me, my email address. It's got encrypted password, so you can see that looks quite hectic. It says I signed in. I've got Facebook there, so that's probably the provider. And it's all of that information. I had multiple ones. I could have me, hi, and anyone else, but it is just a table with rows, and I can query that. So when I did select star, does anyone know what star means in this script? It's a wildcard. It just means select all from users, but I could say select now from users. I'm getting that. I could say where provider, I don't know if it's equals. Oh. Equals.
It's just it's like a place of the
Perfect. Yeah, so there's only one in there, so we're not never going to get too much information out of this database, but that was what your SQL command looked like. Select email from users where provider equals Facebook, or you could say select star, and it'll bring all of them. And that's what's going on behind the scenes. So when you're querying your database, when you fill in your email address, it'll say select star from database where user email address equals this. And then if that comes through, it'll say, does this password equal the same password that we have there? If that's true, then that user will be stored in some sort of information. Fortunate, because we don't have to write SQL as much anymore. I used to have to write SQL on a daily basis for months and months and months just to get the information out. And it was really, I think we were breaking some sort of legality rules where we were, because it's quite dangerous what you're doing. It's like I've got given all of this information that I can just make one typo and just delete everything. I'm so close to the database, it's quite scary. By illegal, I mean not overly legal, but I definitely should have been slapped by other developers. You should never be that close to your data. It's quite scary. There's too much power there. I'm writing SQL commands. I'm not a SQL expert. I'm a Ruby developer, or at the time I was a C# developer. So we have things in place now to stop us writing SQL commands, because I like to write Ruby. So if I were to pull out all of my users, I want to have a place where I can do users.all and have all of my users as an array, or I can do users.first.email. I want to talk to it in a Ruby way. And later on, we're going to talk about ORMs, which is a way for us to do that. But right now, I want you to just have a little play, get everything set up in the tutorial. But as Mihai says, always sort of like tinker and play. Type in PSQL, try and insert into the database using SQL. So look up insert statements, look up select, delete. I forgot where I had it before. I'm seeing a few hands go up. I'm just gonna, where is it? Here we are. We're quite fortunate. So Ruby, everyone keeps asking the question, what are the best Ruby methods to learn? What are like 5 or 6 methods to learn? W3 is cool. We can't really answer that with Ruby because there's so many and they're all fantastic, and we love Ruby. But with SQL, we can say these are the most common methods. So, and I'll say up until about here are the ones that you should definitely know. So for a little while this morning, I want you to have a go building up the SQL commands, inserting things in there. Worst that happens, we can just delete it all. We can drop the entire database and then build it up again. But I really want you to play now because we won't really get too much of a chance to learn SQL. And if you really want to go really advanced your SQL knowledge, I would recommend this tutorial, Learn SQL the Hard Way by Zed Shaw. It's absolutely fantastic. It's one of the best tutorials. It's also got Learn Ruby the Hard Way, Learn Python the Hard Way. I think Learn C the Hard Way is coming soon in hardback. But definitely Learn SQL the Hard Way. Go for as much of that as you can if you're feeling confident and you really want to learn extra SQL. But now, as modern day developers, we don't have to build up SQL. We don't have to type write too much SQL. So that's it for the introduction to kind of the basics of SQL. One thing I've noticed through some feedback we had yesterday is actually building a Sinatra application. So I want to sort of show you pretty much what a Sinatra application absolutely has to look like. So before I continue, does anyone have any questions about SQL? Or questions at all?
Do you have like a database that you can play with?
You'll have a database you can play with.
Really? I just install it.
So if you want to, any database you want to play with, create. Now connected to Playground, and I can do whatever I want to this. And the moment I've messed it up so much, I can just do drop database. And, if you want to drop it, you have to connect to another database. By default, you should automatically have a database called your name or your username. So if you type into Bookmark, you'll always have in Postgres a database of your name. So mine's called Stephen. Don't delete that one. You'll really mess up your computer. Yes. Yeah, so drop a database, and now it's gone. So you can just create a database and drop it. I would actually encourage you to create a Playground database just to sort of have a little play. You can't do too much wrong unless you delete your username database. If we do, because how long does it take to fix? Oh no, you can just, there's a few. You can just create the database again from the outside, but when you type in, no. So when you type in PSQL, what it's actually doing, it's connecting as a user, and the user by default it connects to is whoever you're logged in as. So and that's me, Stephen. So when I do PSQL, it's actually connecting to a database automatically called Stephen. Hence why we have this Stephen here. If I do L, you should see one called Stephen. That's quite important. That and Postgres. I think actually if you delete both of those, you're in trouble. If you delete one, you can still connect as the other, and you should be fine.
It works, but if you delete Postgres,
okay, fair enough. Yeah. So if I delete Stephen, I would have a little bit of trouble trying to reconnect. I might have to Google how do I connect as a different user. It's not too hard, but I would have to do Postgres and then connect as the actual Postgres. So you can play with most databases, but don't play with just two, in short. So have a play, try and write your own SQL. Just get a feel for writing the SQL language whilst you're going through the tutorial. In terms of, hi Sam. Actually, I'm glad you're here. I was just about to start talking about structure for the week in terms of pairing.
Yes.
I would say this week, because it's this tutorial as they go is quite full on in terms of its reading. Does anyone have any trouble pairing and reading? By trouble, I mean, is it a little bit frustrating that you're sort of sitting there in silence? And yeah, I would say have a pair. Switch your pairs at least every day. Just because we're not rewriting, we're not coming up with our own real solutions here. We've got a solution in front of us. It's a tutorial. Just you'll learn so much information by rotating your pairs as much as you can this week, maybe even twice a day. But take the opportunities to really sit back, spend some time reading through the information, and then discussing it. I think the power from this is like almost like a book group where you discuss, you talk about what you've done. You might understand this when we're connecting to Postgres as Postgres. The other person may not. So you can sort of like share on each other's information here, and then pair so much on the code, or even work in isolation and then talk about your solutions together. Have that extra person that you're going to be working with and rotate that every day, but you don't have to be so strict as much that you are constantly with them and reading together and then not progressing while that person's gone to the bathroom and so on. Is everyone okay with that? So I'll say be a little bit more lax this week. You don't have to pair the same person for the entire week. Sort of dip in and out of it as you feel natural.
I was going to add that if you guys are, I think we've been really impressed with how focused you've been in your pairing for the 3 weeks in here. It's been, you know, and I think you've all seen the highs and the lows. Pairing, potentially valuable it can be, but also how emotionally exhausting it can be as well. So I think it's, you know, it's you know, I think it's there'll be more chance for pairing when you're pairing. I guess almost works best when you're generating code together.
Yes, Jake.
I was wondering, when you talk about databases, they seem to say Python. what's the deal with Python and why is it so good with databases?
Python, do you want to answer that?
I was going to say, I don't know that it is.
Yeah, I think you might have been talking to a lot of Python developers.
It's not that Python's very good, a very good language for working with statistics, and so if you're using data.
Oh, for big data,
Yeah.
yeah, there's some excellent sort of big data libraries that go with Python. It's particularly strong there, but that's separate from databases in general.
So Python's like, just like Ruby, it's a programming language that lets you apply logic. It's a bit faster talking to databases, I guess. But yes, it's the same as Ruby in that respect. Richard, do you have a question?
So I know about relational databases have been out for some time. What's the next, I guess, paradigm? I know I've been reading a lot about in-memory databases.
I guess NoSQL has got a lot of traction a few years ago. I don't think SQL's going anywhere anytime soon. This is like, at the very core of like web development is a SQL database. They're getting a lot faster. They're fixing
Relational.
relational.
Yeah, in terms of like in-memory. Where
I don't know.
Yeah, I mean that's partly as well in the boom in the size of memory. The laptops are all stopping having hard disks and they're all having just RAM in there. Then there's a process whereby well, let me contrast it. In the past, and still to an extent, there is a trade-off in terms of the storage devices that you use in computers. In that, the more storage that you want tends to be the slower the access to it. And this goes from like tape drives through hard disks, which you remember your computers always go through, and so on, to you don't know the USB sticks and so on. The profile is approximately the same. If you really want really big storage, then you're going to have to pay in terms of your access times, and that can correspond to then slow performance for your end application. Right? But as the more will continue, just this ongoing production lines. Now, on a USB stick, you can fit what used to be the entire room full of tape drives of your, shall we say. But so you can now get to the point where, for relatively simple applications, you can fit all of the data that you need for the database into faster and faster access types of chips, and it's just the access times are going down. I mean, sort of keeping it these days, the distinction between keeping stuff in memory and having it just stored in the disk is less and less, because they're both different types of chips. And the memory tends to be a more expensive chip. It's faster to access, but is less efficient in storing the memory. So it doesn't, from your point of view, it doesn't really represent any fundamental change. Just that you can, you can put off having to worry about the database and its slowness for longer and longer.
Okay. Are there any other questions on database? Sorry.
Yeah. I'm trying to remember off the top of my head now, but I looked at the pill for the database. It was either that or it was one of the links, and they talked about how to decide which bits of information you'd put in which table, and how you'd link those together. And it wasn't as I would have expected it to be, in that I thought, for instance, I think it was looking at tweets. I would have thought that you would look at what's unique and what is replicated, and so the tweeter is the unique thing, and so you would have one table that's got that, and then you would have all of the tweets, and then you would link the one tweeter up with lots of tweets. But I can't remember whether it was a pill or a link or what I looked at, but it wasn't. I don't know. Was it a link? You know what I'm talking about. I looked at something different, and it wasn't as I would have expected it to be, and so I felt I wanted a bit more clarity on how you worked out what you separate off as different tables.
We are going to be covering relationships and associations in particular, tomorrow.
Oh, okay.
So we can cover up some examples for you to really sort of tackle that one, how you break it down. I think that's a really good question. How do you turn what is data into data. What is, I mean, this could just be, when we had our bookmark manager, this could just be one text file pretty much of everything you see pretty much in front of you, every URL at the end, and we just break it up. Whereas if you click on Game's name, that could take us to everything that he's produced. Or if you click on yesterday, for example, it could give you everything that was about yesterday, or so on. And when we add tags to this as well, so Yahoo and Google might put them into the search umbrella, whereas we could make this kind of like under education. So you've got these tags. So when you click on search engine tag, it will give you that information of like just Google and Yahoo and get rid of this academy. Where would that tag be stored? What is that tag? How do you make that connection between the two? So we're going to cover sort of like how that's made. And as for the Twitter example, I think we'll be tackling that maybe at the weekend. Maybe. So we're definitely going to get there before the end of the week. Martin had a question.
Yeah, there's a concept like this graph database. Graph database is like 4 MJ something.
Mm-hmm.
Is it just on top of the normal database or just instead of the database? How it works?
I'm not entirely sure. I've got a book upstairs. You're welcome to have.
I think that it's usually not on top of the relational database. The graph database itself can be one of those SQL ones that the data is just stored in the graph arrangement, and there's no necessarily strong concept of separate tables. It's just a big object graph, a lot like the kind of, if you think about as we're building objects and talking about composition before, right, where we have one object and it contains references to 3 other objects, and those objects contain references to other objects, and that creates a graph, right? You start from, I don't know if you had like boards or player and linked to board, like a battleships, and then board has, you know, references to, you know, grid, which has a reference to 3 ships. Those, if you imagine those as nodes and points, that is a graph. And so that's another way of, they're also called object-oriented databases or graph databases. And that has the advantage that you don't have to do this translation between the relational tables and the way that most programming languages represent their data. Right? So that's a nice thing. You don't have to worry about all of that. But the reason we like, as we're talking about the relational databases, is that they can be much faster for searching. When you've got that big graph, you try to find things in it can be somewhat slow.
I'm going to detour ever so slightly away from databases and talk about designing a Sinatra application. I'm not going to write much code here. I'm just going to give you a structure that I think you should stick to going forward. And it's just going to be what it will look like. So if I just put it out.
While Henry's setting up, so I've got Steve's setting up. I just mentioned Henry's been speaking to some of you about problems you might have with Postgres, and he's working hard to fix it up there. I think you already had Postgres installed, and this was expecting we didn't, and that's, you know, Henry's working on the solution for you upstairs.
Okay. So right now I've got an empty directory. I'm going to build up, without writing any code in here, what a directory structure should look like. So has everyone got this tree application? So if you just do, if not, just type in brew install tree, and it'll give you this, so you can type in tree, and it will list out all of the directories which I have. And right now all I've got is the current directory. So what are we definitely going to have inside our Sinatra application? Gem file, always. So the first thing I'm going to create is a gem file. Tree. There are certain design choices of what you want to call this, the next file, but I like to call it server. So when you run your application, it's going to run something. So I like to call it server, and that's a personal choice to me. Some people like to call it app.rb, which is the runner, so you can just do Ruby and then run app, or Ruby and then run server. But I like to have some sort of server. So I'll then create a server. So I'm going to touch server.rb. So I'm building it up a little bit more. So now when I want to run this, I can just do either rackup or Ruby server.rb. If I wanted something like Shotgun, or an application which runs a server for me, what would I have then? Some sort of config. So for this, I'm going to use my config.ru. So config.ru, RU stands for rackup, and this is going to be the config file which sets up the configuration of the application to run. So then as soon as I run the application, it's going to go into this config backup. It's going to read the information here, which might have access to the server files, and then start running it. And this file tells me tells the application how to run that. Yeah. I wouldn't have that, no. You might want to, I can show you, I'm going to do a slight bit of refactoring at the end of this to say another way of having it, but this is pretty much a sound way to have your application. So now if I do. Sometimes you're going to be doing it on your own. You're not always going to be using Cucumber. You might just use pure Capybara or Rat Capybara. I would say get used to building it by yourself so you know how all of the components. Like anything, if you don't really understand what it's building, if you're using something to build it all for you, you might get a little bit confused about the setup. So certainly go through the motions of building this yourself. So we've got our gem file, which keeps track of all of our gems. We've got a server, which is going to run the main application, and we've got our config root, which is going to be the entry point where it tells it how to run the full application. So with this, we're going to have certain web things. So in our server, we're going to have our gets and our post and all of those methods which build up our application. The rule about these methods, which you'll see, like, gets, and then a bit of information. Anywhere between this line is all the Ruby code which kind of serves that information. That's kind of called your controller. So this is the root. All of the code after the do and end is our controller. And what it's in control of is getting a bunch of data, getting a bunch of information, processing some parameters, and then giving you a view at the end of it that looks useful to you. So the rule with these is keep it as skinny as you possibly can. So skinny controllers is something you're going to hear quite a lot, and it's certainly something you should really preach for. So always keep this bit of code here as thin as you can. If it needs to do a bit of processing, send it somewhere else. So over the weekend, we're working with rock, paper, scissors. So all of that code, our rock, paper, scissors code, I would actually store that inside our lib. So I'd make a directory called lib, and that stands for library. So that's going to be all of our Ruby code, our library code. And in there, you might have something like something like this. And so we have our lib there. So if we wanted to access any information about rock, paper, scissors in our server, we would require that file and then build up whatever's needed to actually use that information from that file. If we've got a lib, if we type in spec now, or rspec, it's looking for a spec file for us to run. So I'm going to create a spec directory. And Ruby's really nice. That by default, anything that's in the spec folder, it will actually give us access to everything in the lib. So before, when we were building all of our test-driven applications in battleships, we could type in rspec. Anything that's inside our spec directory will get run, and that will automatically have access to everything inside our lib directory, which is pretty cool, and it looks really nice. So if I just do tree again, we have our lib and our spec. So inside our spec, we would have a corresponding spec for what's in the lib. So I'm going to touch spec. We've got this test here, which will test this particular file. We have our server, which is running everything, a config root, which is building everything, running the full application from the entry point, and our gem file, which is keeping track of any gems that we might have. If we wanted to have any views or any templates, where would they be stored? In our view. So Snarch is really nice that it gives us access to the views in that place automatically, so we don't have to do any extra programming there. Snarch just knows that it's going to be in there. If we touch. So generally speaking, your homepage view is called your index. It's just a convention. It doesn't have to be. You could call it home.erb, but you'll see index all over the point, and that's just the index of the website that you have. If we have any public files, we're going to store them inside our public directory. And what's an example of what can go into our public directory? Images. So I heard someone say style sheet files. JavaScript, which we'll be talking about next week, but yeah, definitely. We might call that JavaScript or scripts or JS. So style sheets, yeah. So now if we look at our tree again, we've got our public, which has all of our images. So if we had any images going in there, you might have some sort of assets or something along those lines, but images will do for now. We've got our JavaScript, which is going to have all of our JavaScript scripts. Style sheet, which is spelled incorrectly here, but just imagine that's spelled correctly. Our server, our spec, and then we also have maybe our feature tests, so our cucumber tests, and they will live in our feature file. So if we I think that's near enough it. Do you have anything you'd add to that? So I haven't written a line of code, but certainly this is a really good structure. I would have all of my sort of groups and a little bit of logic to work out a bit of data. This would be the server, so I can run that. This is kind of the heart of the application, which runs from from the beginning. This is where it's which tells it where the heart is. Then if I want to do any processing of information, I would go and maybe get that from some libraries, which will do any calculations. So I'll send some parameters, get that, do some calculations, and then get that information back and send it towards a view. Inside our view, we've got our index ERB. We can also have our layout ERB, which I mentioned to you last week. What this is going to be doing, this is going to be exposed to the users. So they're going to be seeing this particular view. That view can access, never have any logic in your view, have very, very little logic in your view. That is going to be bringing in information from the images, JavaScript, and style sheets, because it has access to all of those public areas, so you can get all of that, so you can tie up everything there. What we're going to be tackling this week, so this is really good for rock, paper, scissors. I would expect rock, paper, scissors to look something like this, with what you have. Now we're learning about databases. We might have some sort of connector to databases. So you might have a database setup file, so it can talk to a database, and you also might have, so we've got lib, which stands for libraries. One thing you're going to start seeing quite frequently from now on is a directory called models. So models, right now, the best way to think about models is something that's going to, a file that's going to represent something in a database. So you might have a model for a user. That's going to be talking directly to a table in a database for a user. Then you might have something called a link that's going to be talking directly to something in the database. So I'm going to add this now, but take a mental snapshot of this. This is rock, paper, scissors. Everything I'm talking about now is going to be sort of database connected. So I'm going to make a directory called models. And inside there, I'm going to have something like users. And it's a Ruby file. Because I want to build out this connection, I might have some additional setup called on those lines. That's going to build up the connection for me into that database. Yeah. Yep. So the server is going to be serving up everything we need to build a website. Rock, paper, scissors is a standalone. So that's just servers like where we exactly. Play, hash, make move, generate random move, and so on. And so this should be fully test driven. With unit tests, this can talk directly to here. With each sort of test that helps you get that logic of playing Battleship, rock, paper, scissors on whatever platform. It could be in the terminal, it could be on the web. Your server is now going to require this file so it can actually make those informations, and it's got access to all the parameters. Your view to your server is quite it's doing quite a lot of work here. So when the server runs, that's what's actually going to load up our just created a database. On tree yet, so I'm on tree. When the server runs, this can now start building up everything that the application needs. So it can start requiring this file here, so we can start playing what businesses. It might run this database script, so it has access to all of this information. You're going to be touching that really, really quickly. And we have our new stuff, which is talking, building up all that data towards the database. Oh yes, yeah, thank you. With models, the convention is you'd always have it singular, because it'll always represent one model rather than all of them. Yeah.
Yeah, in this main server context, where this magic set public, for Sinatra to see the whole structure, is the case in this structure as well? Is it general function to put a new server, or just to link the public folder? Because I don't know how Sinatra sees that.
I think by default this would work. So Sinatra is programmed to see a public file this way, but I'm trying not to write any code intentionally here. But you might have to do a little bit of config to set up where the public folder is. So if we just do, I think it's just set public folder, so Sinatra. Yeah, or a path directed to the public. So if we something like this, so set public folder, and then or this one here tells you exactly where the public folder is going to be and what the file name is. You'll soon find out if your public folder isn't working because you won't have access to any of your style sheets. So you might have to Google around and do this, like set it explicitly where it is. I wouldn't worry too much about that. Cross that bridge when you come to it. And that kind of brings me on to sort of like questions like this. I would say make it a mission, not every single time, but this week, post at least one Stack Overflow problem that you have. And I'll help you write it. It's not to get out of writing answering the question. It's more just as a skill. It's a fantastic skill to have, and even answering questions. If you can answer.
Just I'm agreeing.
Okay. It is a fantastic skill to have, being able to write up your question, and then you'll get feedback probably before you actually refresh the page. We used to have, that's not a lie. We used to have time out of my last company where it was called Stack Overflow time, where you were allowed to spend a few hours just sitting, waiting for a question to come in. Because if you answer a question, you get extra points, and people show up about how many points they have in Stack Overflow. So we were just sitting there waiting for a question to come in, refreshing the page, refresh. There's a question, I know the answer, because lots of questions about a whole bunch of like C# and stuff I wouldn't necessarily know. But when the question comes in, I know. By the time I finish writing the answer, someone's already answered it, and it's really frustrating. And then they get all the points going up. So it's competitive. It's really quick. People like answering it because if they get an easy question they can answer, their output's going to go up and they get more points and they're more likely to get a job. People like answering questions. And also, once you leave Makers Academy, depending on how you play it, I won't be there. I'm joking. I really so we shouldn't be there, and we won't be there to help you out when you're late at night working and getting a little bit stuck. So I would encourage you just to sort of like get your Googling skills down, understanding. It's really hard to Google things, especially when you don't know the problem that you're having. So where do I begin Googling that? It's a huge skill, and I can't really tell you how to Google a problem, and it's quite hard to say, just Google that. But you get an intuition over a short period of time. So by the time you finish this course, you'll learn how to Google properly. Writing on Stack Overflow is another skill. You're writing for a developer, and actually, I don't know if anyone's read any forums. Developers are arseholes. As nice as they come across, but they're really sort of like argumentative. Oh, you didn't do this correctly.
I don't think so.
No, they can be quite argumentative at times, and it's quite intimidating going into this thing as someone who's quite new. It's like going to the gym for the first time. You're like, can I pick up this weight? How do I lift it? And it's quite intimidating when there's always pros around you. Don't worry about that. People will soon pick you up on it. When people are behind the screen at home, they can be a little bit rude for no reason. They wouldn't be like that in real life. Just get over like making those mistakes. Do it while you're here. and we'll guide you at writing Stack Overflow queries just to help you out later on when we're not there to help you. It's a good skill to sort of gain while you're here.
When I look at Stack Overflow queries, a lot of the actual code that they put seems really abstract. Is that because they are deliberately that they're writing a program, they've got a problem, and people are deliberately putting it in the abstract so as not to show you their actual code, or do people just write this really abstract code all the time?
No, it's for exactly that reason. So they might tailor their code to be less in the sort of the domain of what they're working on. So they might be building some sort of really unique system for someone, not for privacy reasons, but in order for you to understand that problem, you'd be like, but what is a I don't know, factorial, what is this? And they might not have those expertise. And really, you just want to say, this is pretty much the problem I'm having. Can you give me sort of like the way to solve that problem? Because you would have a theory about why it's not working.
We probably don't need to do that. We're not working on anything that needs to be kept secret in any way, so we can actually just put our actual code up.
Oh, yeah, absolutely.
And you'll find open source projects, that's always the way. I would say, like, if possible, if you've got a public repo, link to that repo. Because the little chunks of code, it's like, that's good as well. But then, personally, if I'm helping someone out with a Stack Overflow, I always want to see, like, okay, there were the bits that you chose to show me, what else was going on? I want the link to your actual repo so I can then clone it, pull it down, and then I can send you a pull request for the fix, maybe.
And even go as far as, if you've got a relatively interesting problem that you managed to solve yourself, just posting the question out anyway, even though you've got a solution, just to wait and give someone an answer, and then you can actually see if there's a better solution, and you actually understand the solution. It'll make sense. You might even put exactly what you wrote there. So practice doing that as well. Okay, good question.
Yeah, my first question.
And people put a lot of energy into doing that, building their own presence. One thing I would say is in your title, don't put like, here's a quick one, here's an easy one. Don't let them be the judge. So a bit like if you ask questions to us, so if it's got a quick question, there's no quick question, but the answer might be quite long. So don't make any assumptions about duration or ease of the question in the title, because it does irritate people. And I said, here's a question, and so on. I don't think question is an easy question, and then someone ripped in me saying that.
Like, what's up? There's a requirement for to do meet Stack Overflow hosting recommendations. There's a whole series of things like they're trying to stop posting under certain things. Is to, if you're posting the question, then you get the correct answer, tick that one, and then that person's reputation will go up on Stack Overflow. That's what they want. They're you know, I mean, you can say, as long as you say thanks, I think more than like 15 characters, you can say thanks. But what I think people are really looking for is the tick. And if you find an answer that works for you, you see there's little up and down arrows above it. You know, upvote the ones that, you know, if you get value from it, upvote that. It's like tipping people, taking the time to answer the question.
But yeah, so with this directory, make a note of that, and always try and copy that sort of structure.
The database be supposed to be like the main.
Right now, yes. Then I might start thinking about refactoring this if I wanted to. So I might have an app, so to speak. So I might have a app, and my app is going to be mostly the web sort of side of things. Yeah.
Or to say it's entirely my fault, but we could have gone over time.
Yes. So this one, just 2 minutes. I'll move everything over. So I'll probably move everything web related into the app. So I'll say move my views to app, move my public into app, move my server into app. I wouldn't move models. I'd move my so that looks like. So the app now has all of this information. I'll probably move my. No, I'll keep everything like that.
The important thing with Sinatra is to remember that Sinatra is agnostic. It's flexible as regards what this structure is. And there's certain groups of people using Sinatra in certain ways that kind of tend to have certain sort of layouts. But even with the Mix Academy, the kind of layouts that we as coaches prefer might differ ever so slightly.
I personally prefer the previous version, but as things get a little bit bigger, this will be under web section. This will be a standalone for everything else. But with this particular directory, it's really the web, and you can sort of take that out and swap it with something else. Or you can have a mobile application there or something else. But all of this is quite standalone. All of this is quite standalone to what this is and a few of the feature tests. So the web is going to extract it up for the previous one, just for simplicity. But if it gets a bit bigger, I might try and do that. Yeah, so FPT is really where we're going. So N is our models, which I've just showed you. So that's all of the things into databases. We can talk about this in a lot of detail going forward. Just into labels. Our V is our views, and our T is our controls. Controls in this respect is in our server. We call those little methods which are showing information and telling you which view to go to. Control. Okay.